In this video, we will walk you through the AMD Enterprise AI Suite. The suite is a full-stack solution for developing, deploying, and managing your AI workloads on a Kubernetes platform optimized for AMD compute. We will look at two main components. AMD Resource Manager enables optimization of infrastructure through cluster and node management, ensuring high GPU efficiency, providing monitoring and dynamic resource sharing. And AMD AI Workbench that supports enterprises with accelerated end-to-end AI development, enabling you to go from model selection to production in an enterprise setting. Both of these are accessible through a streamlined graphical interface for end-to-end development, deployment, and management, empowering teams to innovate without delay. As you can hear, it's designed to cater to a wide range of users, including AI developers, researchers, platform and resource managers, and many more. Let's have a look at how it works. Now, in the AMD Enterprise AI Suite, we can navigate to the left-hand side where we can see the main components that we will demonstrate today, the AMD Resource Manager and the AMD AI Workbench, with their respective subcategories below. Let's start with the Resource Manager. The Resource Manager delivers a real-time overview of resource utilization and user activity across your resources. It provides administrators with necessary tools to manage and control the computational resources. It's designed for maintaining compute resources, setting up projects, and enabling users to utilize resources for their compute needs. If we look here at the dashboard page, it displays key metrics and workload statistics to get an overview of the connected clusters, nodes, available GPUs, and allocated GPUs. Below, we can see the allocations and workloads, where we can view the consumption per project, including the GPU statistics and an overview of running and pending workloads for each project. Through the Resource Manager, you create projects to organize and manage your work. If you, from the dashboard, want to view a more detailed consumption overview for a specific project, you simply click on it and you get an overview of that specific project, including device and memory usage, GPU idle time, the workloads running in that project, and so on. Each project is isolated from the others, meaning workloads and secrets in one project are not accessible from another. But the compute resources can be dynamically shared across projects based on real-time usage. A project includes users, secrets, storage, and the hardware quota for the workloads, as you can see in the project settings, where we can update the hardware quota for the specific project. The quota we reserve here for a project ensures fair access to compute resources for all users and projects. Going back to the dashboard, below the allocations and workloads, we see the interactive charts visualizing GPU memory utilization and device utilization with trends over time for the different projects that we have running, and where we can adjust the time ranges for a more detailed analysis. Now, let's talk about AI Workbench. The AMD AI Workbench enables developers to manage AI workloads end-to-end. The AI Workbench is designed to offer both low-code and advanced capabilities for developing AI applications by simplifying tasks such as deployment, fine-tuning, inference, and other jobs. The AI Workbench features an AMD Inference Microservices Catalog, the AIM Catalog. A much larger catalog of AIMs from popular open-source models will be available when you install the AI Workbench. The AIM catalog includes state-of-the-art models from the Hugging Face community optimized for AMD compute. From this catalog, you can deploy and connect to the AIM of your choice, or you can fine-tune a custom model in the Custom Models tab by utilizing a base model and a training dataset. If you wish to use your own dataset, you can simply upload your dataset in the Datasets tab. For the advanced users, we offer a library of AI workloads in our documentation under the Reference Workloads page. These serve as a starting point for custom development. They are open-sourced and can be found in the documentation and the Git repository. Let's deploy one of our AIMs by clicking Deploy. This will take a few minutes. The AIM is deployed and we can now connect to it. We have an external URL for connecting to the model, as well as an internal that can be used together with the following Python code snippet if you want to access via the Inference API inside an AI Workbench workspace. Navigating to the chat, we can interact with our deployed models by selecting a model, inputting our message, and we will receive an answer from the model. We can also compare two models. If we add our newly deployed model, we can provide, for example, the same input message, and we can compare the models side by side and see how they respond to the input message. If we navigate to the workload page, we can view all available workloads along with details such as memory usage, workload type, and status. Lastly, the AMD AI Workbench integrates with well-established workspaces including JupyterLab, Visual Studio Code, MLflow, Comfy UI, allowing you to develop applications independently if desired, while still being able to utilize any deployed or fine-tuned model that you're running.